For this assignment, it says to complete each table. Also answer the zeros. So we're looking for zeros and multiplicities without a calculator. So first I'm going to look at number 1, and I can see that this is x to the first power, x to the first power. You're multiplying two binomials together. This is raised to the first power. This is raised to the first power as well. And there's a 1 over here. So those are your invisible identity elements. When you multiply by 1 or raise to the power of 1, it does not change what you see. So without multiplying it out, I can say the a value is 1. The degree is, let's add these together. We've got one binomial here, plus 1 is 2. So this would make this function a quadratic. This is something that you should be familiar with, but we're going to write this down right here. You should have seen quadratics often in Math 1 and in Math 2. All right, so we know that a quadratic makes a U shape, and because that a value is positive 1, there's not a negative out here, it's going to go up. So this is how we describe the end behavior. It's going to go up to the left and up to the right. Now let's do that mathematically. All right, you should have these notes in your workbook. And I'm looking at the a value is positive and the degree is even. So even and positive. So even and positive gives you a graph that looks like this. Okay, so that's what we said. So your f of x is going to be going up, approaching positive infinity as x approaches negative infinity. That's like saying as x moves on the axis to the left, y is going up. And it's also going to go up on the right as x approaches positive infinity. F of x, or y, is going up. So let's copy that down and get used to this notation. So this is going to be f of x is going to approach positive infinity. And I'll just go ahead and write that down twice. Both as x approaches negative infinity on the left and on the right as x approaches positive infinity. Okay, so that's how we write end behavior. Practice that with these 6 problems. You'll see that, and we need to know how to write it and how to recognize what that's saying. All right, our zeros, without graphing, are going to be here. We set x plus 2 equal to 0. And when we solve for x, you would subtract 2 from both sides, and you would get x equal negative 2. And let's check that. Negative 2 plus 2 is 0. Now, if we set x minus 1 equal to 0 and solve for x by adding 1 to both sides, you'll get x equals 1. So we have 2 solutions, 2 places where this is going to cross the x-axis. And with the parabola, what happens at those zeros is going to pass straight through. It's going to pass straight through here and also here. Okay, now we haven't listed the multiplicities. So what multiplicities tell us is how many solutions we have at x equals negative 2 and at x equals 1. Okay, we get that by looking up here. To find x equals negative 2, we use this binomial, and it's raised to the first power. So we have a multiplicity of 1. That means it's going to pass straight through. It's not going to bounce. It's not going to curve. Also, at x equals 1, we have a multiplicity of 1 because you can see that this binomial is also raised to the first power. Now let's move. We're going to check these later with our calculator by putting this into the calculator and verifying that this is what we see. For the second one, again, my a term, if I multiply this all out, would be 1. And it's a positive 1. There's no negative out here. It is of degree 3 plus 1 right here is 4. This is going to be a quartic. Not a quadratic, but a quartic. Okay. We want to know what the end behavior is. So we want to know what the a value is, positive or negative, and what the degree is. So it's even and positive, which is the same thing that we had here. So the end behavior is going to look the same. F of x is going to approach positive infinity on the left-hand side as x approaches negative infinity, and f of x is going to approach positive infinity as x approaches positive infinity. So it's going to go up on both sides. I'm not sure exactly where this crosses, but it'll go up on both sides. All right, the zeros are at 2. We can add 2 to both sides if we set this equal to 0 and get x is equal to positive 2. Set this factor equal to 0 and solve for x, and we would get x is equal to negative 4. All right, but let's look back here at x equals 2. This has a multiplicity of 3. So I'm going to write MULT, just to abbreviate it, of 3. And this, at x equals negative 4, is going to have a multiplicity of 1, because that binomial is raised to the first power. There's only one of those. So what happens at those zeros? Okay, so if we look at this graph, when we have a multiplicity of 3, okay, I'm not sure what's happening down here. In a quartic, it can be doing some up and down things, usually. But at the multiplicity of 3, before it crosses, this is an odd multiplicity, it's going to hug. Any odd multiplicity is going to hug greater than 1. But multiplicities of odd multiplicity, this 1 is going to pass straight through. So this is going to be a pass straight through. And by hug, what we mean is it's going to come down to the x-axis, and before it crosses through, it's going to flatten out a little bit. Okay. All right, now let's go to question number 3. All right, so for question number 3, our a value this time is negative 0.02. Okay, so it's negative this time. And the degree, look at your binomials. Look at what you're multiplying. I've got 3 here and 2 here. So when you multiply this all out, when you expand it, then you're going to have the highest term is going to be, the leading term is going to be an x to the 5th. Okay, the end behavior, let's look at our chart. So odd, degree, negative. So we're going to look at odd and negative. So it's going to go up in the second quadrant and down in the fourth quadrant. We're not worried about what's happening here. We just want to know it's going up and down. Okay, so how do we write that? We write that f of x, which is our y, is going to be going up positive on the left. So we say when x is going to the left, we write it this way as negative infinity. Y, or f of x, is going up, positive. But on the right-hand side, f of x is going down to negative infinity as x approaches positive infinity. Now let's look at the zeros. We have a 0 here at x equal negative 3. You would subtract 3 from both sides after setting this equal to 0. If you set this factor equal to 0, x minus 6, and solve for x, you get x equals positive 6. So here are the two places where it touches or passes through the x-axis. And we determine what that behavior is by looking at the multiplicity. So let's look at x minus 3. This is to the third power. So what's going to happen is it's going to flatten out and pass straight through if it's odd. If it's even at 6, and let's write down the multiplicity. I forgot. The multiplicity is 3. At x equals 6, this is of degree 2. The multiplicity is 2. So that's going to be a bounce. Any even number is going to be a bounce. The higher we go in multiples of 2, the flatter it gets before it bounces. So here, what happens? It's going to hug. This is one way we described it, or flatten out before it passes. It's going to hug and then pass. Okay. Up here, it was a pass straight through. And then a multiplicity of 2 is going to be a bounce. Okay. All right, question number 4. All right, we have a leading coefficient. If we expand this out, or I can just look and see, our a value is going to be 1, and it's going to be positive. The degree is 1 plus 1 plus 1 is 3. And then the end behavior is going to be odd and positive. So let's look at our notes. Odd and positive. So it's going to look like this. It's going to be going up in the first quadrant and down in the fourth quadrant. I'm not really sure what's happening in between, but I do know it's going up in the first and then down in the fourth. So the end behavior, f of x is approaching positive. Let's go ahead and do the right-hand side. Approaching positive infinity as x is approaching positive infinity. And f of x, or y, is approaching negative infinity as x is approaching negative infinity. The zeros are at negative 1, x equals negative 1, and it has a multiplicity of 1. All right, at x equals negative 2, we have a multiplicity also of 1. And then at x equals positive 1, we have a multiplicity of 1. So all of these are going to pass straight through. Okay, let's go to number 5. All right, here I have a negative 0.01. All right, I have no other numbers here, so it's easy for me. If I expand this out, I know that's what I'm going to get in the beginning. Okay, our degree is 4 plus 2 is 6. Again, if I expand everything out, combine all my like terms, and put it in standard form, the highest degree term is going to be of degree 6. So let's look at what the end behavior is going to look like. Even degree, negative a value. So even and negative. So it's going to look like a parabola. Okay, it's going to go down. Okay, so it's going to go down on the left and down on the right. All right, so the end behavior, y, our f of x, is going to be approaching negative infinity on both sides. As x approaches negative infinity, it's going to go down. And as x approaches positive infinity, it's also going to be going down. Our zeros are at x equals 3. Set each factor equal to 0 and solve for x. So x is equal to 3. And here, x is equal to negative 7. Okay, now we want to look at the multiplicities. It will tell us more about the graph. Oh, I got that backwards. Multiplicity. Okay, so right here at x equals 3 has a multiplicity of 2. So that's going to be, let me draw an arrow, it's going to be a bounce. And here at x equals negative 7, it has a multiplicity of 4. So that's even. It's also going to bounce there. So up here, it's probably going to do something like this. I don't know. But you can look at your graph. You can go back and use your graph to check your answers. All right, for question number 6, the a value, you can multiply it out, or you can just take it here, because I see there are no other numbers in here to multiply. So that's going to be 2. The degree is 2. The degree is 2, 3, 4, 5. This is a quintic, just for your reference in case I say that. And degree 4 is a quartic up here. Quartic, quintic, quadratic. All right, the end behavior, okay, it is odd and positive. So I'm going to go here to odd and positive. It's going to be going up on the right and down on the left. So f of x is going to be going up, approaching positive infinity on the right. So as x approaches positive infinity, and it's going to be going down. So it's going to be going to negative infinity on the left. Okay, the zeros are at negative 7, at positive 4, and at positive 2. So what is happening at x equals negative 7? We have to find the multiplicity. Multiplicity here is 2. It's even, so it's a bounce. At 4, okay, that's of degree 1, and that's going to pass straight through. And then finally, at x equals 2, this is of degree 2. Let me write multiplicity of 1 here. And here is multiplicity of 2. So that's going to be a bounce right here. Because Math 3 is calculator active on the EOC, we first did this assignment without the calculator. Now we're going to be using our calculator to check. So I put in the 6 functions, a of x, b of x, c of x, d of x. Now I changed the e of x because e represents a number like pi. So that's a special number and it won't graph correctly. So I went ahead and just chose a variable for this. And I changed the e of x to g of x. And then the last one is f of x. So now I'm going to look at the first graph to see if my predictions are true. So I predicted that f of x is going to approach positive infinity both on the right and the left, which is what happened. And then it is a parabola because it's a quadratic. Okay, I'm going to turn that off. Then I'm going to turn on function b. And let's see if this is what actually happened based on what I answered. So I said at x equals 2, this root or this solution here, that it was going to hug before it passed through. So that's where it curves, flattens out a bit, but then it passes straight through, or passes through, not straight, but it passes after it hugs or curves. This is a cortex, so I expected a couple of bumps. There's one, here's one. But on the left-hand side, at this root, it's going to go up to the left. And that's what I predicted. That's what I got by looking at the equation. So I'm going to turn this graph off and go to graph C. All right, I predicted that as x approaches negative infinity on the left-hand side, f of x would be going to positive infinity, which is what happens. And then as x approaches positive infinity, f of x is going to be going down, which is what happens. And then with the multiplicities at x equals 6, I said there was going to be a bounce. It had a multiplicity of 2. And at negative 3, there was going to be a hug. A hug is a curve before it passes. All right, so that looks correct. Then I'm going to go to D, graph D. I may want to zoom in a little bit more to actually see what happens because it kind of goes above the x-axis. I can see what my roots are, my solutions. I want to click on those. We didn't really, well, actually that was part of the question. So I can check to see if I got those correct. All right, so this is graph D. So look on your paper. We predicted that f of x is going to approach infinity as x approaches positive infinity. So on the right, y should be going up. On the left, as x approaches negative infinity, y is going to be approaching negative infinity. So it's going to be going down. So that looks correct. And I can check my roots real quickly. All right, now I changed this one from e of x to g of x because we should never use e in our calculator. That's a special number like pi. So I changed this to g of x. That's going to match number 5. All right, so I predicted it was going to go down on both sides because this is of degree 6. And let me zoom out a little bit. And that's what it looks like happens. On the left, it's going down. On the right, it's going down to infinity. So we wrote that as x approaches positive infinity, f of x goes down to negative infinity. And on the left, as x approaches negative infinity, f of x is going down to negative infinity. Okay, now we're going to go, we can also check our roots. I'm going to zoom in to do that because it's really hard to see so close what happens here. See, I said that there was a root at negative 7. Yep, there's a root right there. And I said that there was also a root at 3. So let me move over here. And here's the root at 3. There we go. All right, so those two roots, this is a bounce. That's a multiplicity. It's an even multiplicity. And I looked to see that that was a multiplicity of 2. And over here, this is also a bounce, but notice that it flattens a lot. So it's going to be a higher multiplicity, and it's a multiplicity of 4. So let me turn that one off and turn on f of x. And let me zoom out a little bit so I can see where it crosses. Okay, I see my roots at negative 7, 0, at 2, 0, and at 4, 0. Now it's going to go straight through at 4, 0, so that's a multiplicity of 1. All right, so that multiplicity of 1, I check my paper at x minus 4, that is raised to the first power. Here is a bounce, so that's going to be an even multiplicity, and it looks like a multiplicity of 2, and that's what happened. And then here at negative 7 is also a multiplicity of 2. It doesn't seem to flatten out, it just hits and bounces. All right, that's how to do this assignment. Thanks for watching.